Good morning. Today we'll be focusing on the classifications of connective tissues, and we will be looking at specifically the category of connective tissue proper. The first part that we'll discuss is the common origin of connective tissue, which comes from the mesenchyme or an undifferentiated stem cell. Some key components with connective tissue proper is that the connective tissues connects the epithelium to the rest of the body. There's always three main components to connective tissues. They're specialized cells, they have an extracellular protein fibers, they also have a ground substance which is highly vascular and also contains sensory receptors that detect pain, pressure, temperature, and other stimuli. When we're looking at the categories of connective tissues, they are all going to have similar functions. They're either going to bind structures such as ligaments, bind bone to bone, or tendons bind muscle to bone. We're going to find them transporting fluids and dissolved materials such as fluid connective tissue of blood and lymph. They help protect delicate organs. We find this in the bones of the cranium, sternum, and rib cage. They provide a support or structural framework, such as supporting the trachea, the ears, and the nose. They also store energy reserves, especially in the form of lipids. Fat is considered to be the major energy reserve in the body. And finally, they do have a function of an immune protection, such as leukocytes are also called white blood cells. So the first part of this lecture will be focusing on connective tissue proper. We'll be looking at the loose connective tissue, and specifically they have fewer protein fibers and more ground substance. And then we'll switch into the dense connective tissue, which has more protein fibers and less ground substance. They're broken into specific connective tissue categories based off their function and location. We have first in the loose connective tissue, we have the areolar connective tissue, and then next we have the adipose connective tissue, and finally the reticular. And then we'll be moving forward into the dense connective tissues of the regular dense connective tissue, irregular dense connective tissue, and finally the elastic connective tissue. So the first part of the discussion will be getting into connective tissue proper. With connective tissue proper, it's going to have an extracellular fiber, or what we consider to be protein fibers, and some sort of a ground substance. So these two components are going to form what we consider to be the extracellular matrix. So the extracellular matrix, within the ground substance, we're going to see that there's going to be cells and protein fibers that reside, which are composed mostly of protein and carbohydrate molecules and water. Ground substance can be viscous, such as blood. It can be semi-solid, which we find in cartilage, and in ground substance can also come in a solid form that we find in blood. The protein fibers that we see, there's usually three categories of the proteins, and they're based off of their strength and characteristics. The first one is the collagen fibers, which are strong and stretch resistant. The next one is the reticular fibers. These reticular fibers have an interwoven framework that is extremely tough. You can see, I'll just kind of draw over one here, but they form this crisscross or interwoven framework that's tough and flexible. This interwoven network stabilizes the position of some of the functioning cells, such as a macrophage or an adipocyte. And it resists forces from many directions. And finally, we have the elastic fibers up here. They're shown as being a little bit a darker shade and a little bit thicker, and they have a little bit more flexibility and resiliency. So when we're moving into resident versus wandering cells, this slide really goes over the key components of a resident cell. So resident cells are ones that are stationary cells and are permanently contained within the connective tissue. Their job is to support, maintain, and repair extracellular matrix. So the resident cells that we're going to be talking about are the fibroblasts, the adipocytes, the macrophage, and the mesenchymal cells. Within all connective tissue, we also have some wandering cells. They're continuously moving through connective tissue and are involved in immune protection and a little bit of repair of any damage to the extracellular matrix. This slide doesn't show them, but an example would be a mast cell, a plasma cell, free macrophages, and some other leukocytes. So the first one that we'll start discussing is going to be the fibroblasts. And with the fibroblasts here, they're the most abundant. They are derived from monocytes. Oh, excuse me. They're the most abundant and the only cells that are present in connective tissue proper. They have the ability to produce protein fibers and ground substance components of the extracellular matrix. So they're directly linked into the production of ground substance. The next one is the category of macrophages. This one would be considered to be a resident cell, so it's called a fixed macrophage. They are derived from monocytes. They resemble very similar to a large amoeboid cell, and they're scattered throughout the matrix. Their job is to engulf pathogens or destroy damaged cells that may enter into the tissue. The next one is the adipocyte or fat cells. These adipocytes contain a single nucleus located here inside of an enormous lipid droplet. Their nucleus, organelles, and cytoplasm are all squeezed to one side. So you can see in this example here, I'll just point to it, how all of the organelles, nucleus, and cytoplasm are squeezed off to the side. These have a high amount of energy reserves for use by the human body. And most importantly, all connective tissues are derived from the mesenchymal cells, and they're actually located within all connective tissue as a resident cell. Mesenchymal cells are a type of embryonic stem cell. So if there is injury, this mesenchymal stem cell right here will divide due to a local injury. One of the stem cells will divide and become a new mesenchymal cell, and the other one, the other division of the cell, becomes a committed cell that migrates into the damaged area, and then it differentiates into a type of connective tissue cell that is needed. So anytime there's an injury, for instance to a fibroblast, a mesenchymal cell will divide, it'll create a new mesenchymal cell, and then that undifferentiated cell, mesenchymal cell, will turn into a new fibroblast to maintain the ground substance within the extracellular matrix. So the next part we'll be doing is just breaking down or going through the different types of loose connective tissue. Some characteristics of loose connective tissue. The packing material, they're considered to be the packing material of the body. They fill spaces between organs. Their job is to cushion and stabilize specialized cells. So the first one we'll look at is the areolar connective tissue. It has an open framework, and what that means is that it has a viscous ground substance, and it accounts for most of its volume of the cell. So it has a high amount of ground substance, which also goes into its function, which its job is to absorb shock. It also contains high amounts of elastic fibers, so it makes it resilient. It can distort from damage. It does have fibroblasts scattered throughout to help maintain the extracellular matrix or ground matrix. We see this form the padding between the skin and the muscles. This is also a very common injection site for shots. The next loose connective tissue we'll look at is the adipose tissue. As mentioned a little bit earlier, we see that the adipocytes or fat cells are tightly packed. The within inside of this, what we see, for example, is its job is for storage of energy. It also cushions organs. With the areolar connective tissue, its main function is to store energy and protection. The nucleus is squeezed to one side, along with the organelles in the cytoplasm, and we mostly see this in subcutaneous fat. And finally, the last loose connective tissue that we see is called the reticular tissue here. With the reticular fibers, the ground substance is a gel-like liquid. It has a very scattered arrangement of reticular fibers. Its job is to provide a structural framework for the spleen, lymph nodes, the thymus, and bone marrow. We usually find this in the areas of the spleen and the lymph nodes. So moving on to the next category, we'll be looking at is going to be the dense connective tissue. So this is the connective tissue proper, and this is considered to be the category dense connective tissue. With the dense connective tissue, most of the volume of the tissue is occupied by fiber or collagenous tissue. So we see that we're starting to reduce the amount of ground substance, and we start to see this packed parallel collagen fiber. With the dense connective tissue, we also see that it has a high numbers of fibroblasts, and their function is for, we see these in tendons and mostly ligaments, but attaching muscle to bone or bone to bone. They are very good at resisting stress in one direction. The next dense connective tissue that we'll look at is called dense irregular connective tissue. This is what gives skin its strength. We see that the connective tissue forms an interwoven network. So the collagen fiber bundles are a mesh work in no consistent pattern. With this, we see it can withstand stress in multiple directions. We see this as the chart shows in the dermis and the skin. We also see this in the perichondrium covering and also organ capsules. And the last one in the category of dense connective tissue is the elastic connective tissue. It has predominantly high amounts of elastic fibers. These are branching. And we also see that the fibroblast nuclei here occupy some of the spaces in between the fibers. These are considered to be allowed for stretching, so their function allows for stretching of some organs. Specifically, we see these in the aorta wall, and they can stretch and also recoil. We also see elastic tissue, which helps stabilize the vertebrae of the spine. And that concludes the connective tissue proper lecture.